a 12 question paper, seen them ask questions specifically on this. You can go and have a look at all the past question papers and stuff you can get. Questions like we have today is questions that normally does not happen. So why do we do this? We do this just to get to a place, which we're going to do today, where we factorize a cubic function. Because that is important for the next chapter, which is differential calculus, where we will be drawing a cubic function. So in short, all that you just need to know is, what is the factor theorem and what is the remainder theorem? So the factor theorem said that whenever I substitute a value into any polynomial, we'll explain to you where we get that value just now, and I get an answer of 0, it means there's no remainder, which means the thing that I substituted is a factor of it. Alright? If I do get an answer, it means it's not a factor, and the answer that I get is the remainder, the thing that is left. Okay, so what they got to is they say if it's divided by something, the thing that I substitute is always the solution to the thing that I'm dividing with. So what do I mean with solution? If I divide by ax plus b, I'm going to substitute the solution of that thing. So solution means set that equal to 0, so it's going to be minus b over a. So if I put it in there, that will be the thing that I substitute there. Okay. So we did an example or two on the other day, and I ask you to please go and have a look at number 3 and number 5 on page 136. So on page 136, I already did it. I had some time during previous class. So they gave me, at number 3, they told me fx, which is that. And I actually made an error there. It should be a 3 and not a 2. And then it said gx is that. Alright, so what happened next is the first question said, determine the remainder if I divide fx by gx. Okay, so what does the rule say? I get the solution to the thing that I divide with. So if I set that equal to 0, you don't have to show it, you can do it in your head. Back, on front, opposite sign. The answer is a half. If you set a half in there, you're going to get 0. Okay? If you take that thing and you substitute it into that, the answer that you get will be the remainder, which I did. Have a look at how I write it. I say the f of a half. Where do I get the half from again? 1 over 2 opposite sign. Always like that. Back, over front, opposite sign. I substitute it in, I take my calculator, I get 15 over 8. That 15 over 8 indicates two things to me. It indicates to me that that is not a factor of that thing. Why? Because if it's not, it's a factor. The second thing that it indicates is, that is the remainder. In other words, plain English, if I ask you and say 9 divided by 2, the answer would be twice with the remainder of 1. So, yes, that thing can divide into it, but the piece that is left is 15 over 8. Okay. Second question was a nice one, but I say again, very nice question, but you can go and have a look. Never asked in grade 12. Okay. There could be exceptions, but I mean, this is not rocket science. This is not the most difficult thing you've done. You do it for examples, you need to it, and you'll be fine. 3.2 says f fx. And all that they then did with fx is they just took the 3 out and made that a k. And they say, what would the value of k be? I think it was k, am I correct? Yeah. What would the value of k be if that gx is a factor? So immediately, what do I know? That means if I take that gx and I put it in there, what would the answer be? 0, because that's what the rule says. If it's a factor, it's 0. So I did that. Look at what I wrote. I said, if a factor, then the f of a half is equal to 0. Which I then did. Look there. Exactly the same. The only thing that differs is not k, it's actually p. Am I correct? Yeah. So everything is the same. The only difference is now I don't know what that is. That is p. And why do I put it equal to 0? Because they said it's going to be a factor. And if it's a factor, it's equal to 0. And from there, it's really easy. Type it in on your calculator. P is 9 over 8. So if there is written a 9 over 8, then that thing will be a factor of it. Okay. Number 5, pretty similar to that. Number 5 said the following. Number 5 gave you that. It said, and there's the k that I was speaking of. So number 5 written said, if fx is equal to that, determine the value of k if the remainder is 60, if divided by x minus 3. So what I'm going to do, I'm going to divide by x minus 3. What do I know is going to happen? The remainder will be 60. So, the solution to this thing is what? X is 3. Back divided by front, opposite sign. If I now take that 3, I substitute it in here, what would my answer be? 60. They told me that. They said there's a remainder of 60. So, I did that. Look there. If remainder is 60, then I'll write a little sentence. I'm telling them what I'm going to do. Then the f of 3 is equal to 60. So, I did exactly that. Everywhere with this next, I just put in a 3. And you see here as well. And then, ladies and gentlemen, if you solve it, you can get k is equal to 4. So the most important thing that you need to understand today is this. Factor theorem. If I substitute something and I get naught, it is a factor. It means it divides into that without giving a remainder. Perfectly fits into that. If it's not 0 that I get, then it is a remainder, which means it's not a factor and the number that I get is the remainder. That's the most important thing to understand. So what am I getting to today? So today's date is this. Today's date is the 22nd of the 6th month, and you can write there and say factorizing cubic functions. And this is where we are getting towards. And I'm nearly done with this chapter, because after I've factorized it, we're going to solve it, which is the same thing. I'm just adding it equal to 0, and then I'm going into differential calculus. So factorizing of a cubic function. What is a cubic function? I'm going to use the example they have on the board there. Example number 1 said, they give you this. X to the power of 3 minus 2x squared, and then they say minus 5x plus 6. Now grade 12, that is a cubic function. That is what we're working towards in the next chapter. We're going to draw a picture of that in the next chapter. So if I summarize everything together, in grade 9 we started off with linear, the straight line, x to the power of 1. Remember that? Y equals mx plus y. I hope you remember that. Then in grade 10 we got to what? The parabola, which was the quadratic function. Smiley or sad? And from there was some others as well. The hyperbolic function that had its standard form, the exponential function that had its standard form, and so forth and so forth. But very important is, up to now, we could have only solved the following equations. We could have only solved linear, which is x one side, value is other. Then came quadratic, where we set everything equal to naught factorized. Then there's exponential, where x is in the exponent, and then there's inequalities. That's what we can do. Now I'm going to teach you another one. The fifth one is how to solve x here. So the easiest way to solve x here, you know what's the easiest way? This way. But now not all of us have this thing. And secondly, how much marks you're going to get at the end of the year? I think 1. They want to see how you get it. But let's see what this thing says before we start off. So, for those of you who are lucky enough to have this one, it goes like this. Mode, I'm looking for equation. There is your cubic function. The one right at the bottom of my screen, depending on your model and variation and what, I'm going to press 4. Now remember, any expression, the mathematical good manners says I write it in descending order of exponents. So I'm always going to do x3 first, x2, x and then no x. x1 and then no x. So that's how this works as well. So A is x3, B is x2, you understand that thing? So if I go to this then, I'm going to have, what's my A? A is 1. So I'm going to have 1 equals. What is my B? B is the thing in front of x squared, which will be negative 2. What's my C? C would be the thing in front of my x, which is negative 5. And D will then be my constant, which is positive 6. And remember I say equal, it's like a computer, and it's going to tell me x1. So what do we expect will happen? 3 answers. Not always, but most of the times. We're going to get to the not always. What happens if it's not that? So it's -2, it's 3, and it's 1. So to put it in perspective, this is what it's going to get to. So there's my x-axis. So it means to me, and I already know, that this is a positive graph. So this thing would look something like this. That's what it would look like. That's what's going to happen in the next chapter. Yes?
So the x's that you just got on the calculator, are those the factors?
That's the factors, correct? And on the picture, that's your intercepts. That's that 3 things over here. Okay, so that's what we're getting to. Okay, but now, sir, I don't have a calculator. And number 2, sir, if I do that, I only get 1 mark. How does it work? Congratulations, the factor theorem. So, ladies and gentlemen, when I ask you to factorize that thing, the first thing you need to do is, you need to get one of the factors, one of them. Okay, you have to have a start. When I sit in front of you, you look at me like, yes, you start substituting. Where do you start? You start at 1. You take 1, you substitute it in there. What do you want to get? 0. Why? Because the rule says, if I put it in, and I get 0, it is a factor, isn't it? So I take 1, I put it in, I see if I get 1. If I don't get 1, I take -1. If I don't get 0, I put in 2. If I don't get 0, okay, so what if the first one is 333? It will not happen. The people are not drunk when they set the question papers. They think a little bit here. So your first one will probably be 1, 2, or 3. That's normally going to happen. So if you don't have this calculator, you start substituting until you get 0. If you have this calculator, then you cheat a little bit. So if we go back to what I have here, you remember the answer said the following. Let's just check them again. It said -2, it said 3, and it said 1. So what it tells me is those 3 of them are factors. Which means if I take any of those 3 and I put it in here, what am I going to get as an answer? No. So I'm going to go for the one that says -1. You can go for any of them. I'll just go for the lowest one. So, have a look here. Now I'm going to call this fx just for the exercise. Actually, you have to actually tell me beforehand what it is. So let's say it's fx. So what I'm going to do is this. I did not cheat. I'm actually going to always do everything to the book. Right? To the book. So I actually cheated with the calculator. I'm going to make them think I did not. So we saw that -1 is one of them. So all that I'm going to do is this. I'm going to go and say the f of -1 equals -1 to the power of 3, 2 minus 1 squared, minus 5, minus 1 plus 6. What do we know is the answer going to be? Where's minus 2?
That's supposed to be minus 1 is supposed to be minus 2.
Oh, it's a positive 1. I see that now. Sorry. Positive 1. Okay, that's going to be 0. You can check it. Sorry, guys. So if I take my calculator, I'm going to get 1 to the power of... Okay, let's just get to the right mode. Computer. So it's 1 to the power of 3 minus 2 to the power of 1 to the power... Oopsie. Where am I now? Alright, so then it's minus 2, 1 squared. Then it is minus 5 and 1. And it is plus 6. Boom, there's the note. So now I tell them, and I knew that because I cheated a little bit, and I write there 0. So here's my factor theorem. So I didn't know that. If I get 0, that is a factor, but now be careful. And that should be 1, correct? I put in minus 1. That should be 1. So with what did I divide? Think carefully now. Yes. Full marks. So therefore, x minus 1 is a factor, ladies and gentlemen. Where do I get that x minus 1 from? So what you would have seen the whole time happening is back divided by front opposite sign. So 1 over 1 opposite sign is a plus. That's the thing that I substituted to get to the north. I substituted 1. So just remember that you need to go back to the thing that I divide because that's what factors is. Yes?
So the x minus 1 that we see, is that to show that it shifts the 1 to the right?
Minus 1. No, it's got nothing to do with that. No. This is actually just one of the x-intercepts when you draw the graphs. It's nothing to do with... Yeah, later on you can say that, but there's not a real general equation. This is the norm. So we can see that, yeah, it doesn't really know. So, ladies and gentlemen, now what happens now? Now I know that this thing is one of the factors, x minus 1. Now I need all of you to listen. You can go and write this down later on. Everything is in your textbook. Listen now. So after I've got one of the factors, what needs to happen now? I need to get the rest of the factors because there's going to be 3. We said it at the beginning. It's a cubic function. There's 3 answers in most cases. So how do I get the rest of the answers? Here we go. So I take that x of mine and I multiply it with the first one in the one that was given. Not multiply, I ask myself the following. I say, with what should I multiply that x to get to x to the power of 3? And what would the answer be? The answer would be x squared. Fantastic. Now I go and take the negative one. So the negative one, and I ask myself, with what should I multiply that negative 1 to get the constant at the back? And what's the answer to that? Negative 6, correct. Minus 1 times negative 6 is positive 6. So here I get negative 6. And then you do the following. This immediately, you can see is a what function? Quadratic. Why? Because it's x squared. So to me, there's something missing at this stage, correct? Because the normal quadratic had 3 things. What's the thing missing? The thing in the middle. That thing is called bx, and you can call it plus bx for now. Okay, so I'm going to stop before I go on. So step number 1, I'll write it down. Factor theorem to get the norm. If you don't have the silver calculator, you start substituting until you get 0. You don't have to even write it down. Only write down the one you get. Right. Step number 2. First one with first one, last one with last one. What do I multiply to get that? Here it is, bx in the middle. Now, very important, ladies and gentlemen. Now you multiply the following. So now I say, those 2 and those 2 I multiply. Okay, so on the side, with a pencil, you can go and do the following. So I'm going to say, all right, what is minus 1 times x squared? Am I correct in saying minus x squared? What is bx times x? Plus bx squared. Okay, what is that going to be equal to? Now you go back to the top one. All that I see in that is x squared. You agree with me? So if I go back to the top thing, I'm going to look at this thing with the x squared. So in other words, what I'm telling you is that and that is equal to what? Minus 2x squared, the thing in the equation at the top. And now you can actually make all the x's fall away. So I'm left with minus 1 plus b is equal to 2. Of course, the x's will just cancel out. Okay. And now what happens now? 1 goes across, and that's actually minus 2. I forgot the minus from the top. 1 goes across. I add it if I go across. Minus 2 plus 1 is minus 1. And ladies and gentlemen, that you do with pencil on the side somewhere. They don't even mark this. I go back to my equation, I erase this, and I fill in that. Minus x. Fantastic. What is that thing in the second bracket now? Isn't that the quadratic equation or expression? Can you factorize that? Yes, you should. That's a grade 9 factorization problem. I need factors of 6 to subtract to get 1. The answer is 3 and 2. So now it's going to look like this. X minus 1, X and 2, X and 3. Signs will be different. The biggest one will get a negative. Minus, plus. And congratulations, boys and girls, there you have factorized it. And you don't need to now say X is 1, minus 2 and 3 because I did not say solve it. It is not an equation, this is expression. The answer is factorize. Done and dusted. And that, if I'm not mistaken, is exactly what the calculator told us. He said the answer of X was minus 2, 1 and 3. Isn't that true? Minus, it's 1, minus 2 and 3. That's what it was. Sure. Yeah. I know this is like in grade 11 when you do completing of the square. It's like, sure. Just practice it a few times and you'll get used to this. This needs to be done when we get to the next chapter and we draw the graph. Otherwise, how on earth will you get to the intercepts? Okay, so let's do another one. Those of you who'd like to listen. Those of you who understand. Those who want to sleep. Whatever you feel comfortable with. So here we go. Okay. Example number 2. Example number 2, I'm going to take it from your textbook. It says the g of x is equal to 2x to the power of 3 plus x squared minus 13x plus 6. They asked me to factorize that thing. So step number 1. Step number 1 says factor theorem. So you take your calculator if you don't have the smart silver one and you start substituting. Let's see what happens. I'm going to do the substitution now. 2, then it's 1 to the power of 3 plus 1 squared minus 13 and a 1 and a plus 6. I get minus 4. That doesn't work. My next one is, it's on my computer now. I'm just going to put negatives in there and see what happens. So if I put negatives in there, I get 18. Doesn't work. What do I do now? Now I take it out. I'm going to put a 2 in there. So I'm going to start with negative 2. So this is basically what you do. Ladies and gentlemen, you just see, oh, it's 20. Doesn't work. So now I go and I say, right, take the negatives out. Let's see what happens with 2. So if you don't have this calculator, that's what you do. And look at that. Then I get 0. So in other words, if I substitute 2 in there, the answer is 0, which means it's part of my factor. So now I write it down. So I'm going to start off by saying the g of 2 equals 2 to the power of 3, 2 squared, 13 times 2, plus 6. We already worked it out and it said 0. What is my deduction? Yes, Chantal, I'm all ears.
So if you look at the calculator, it gives minus 3 first, so can we do minus 3 instead of 2?
Yeah, it doesn't matter. Doesn't matter. As long as you just get 1 there. Right. So I took 2 and I get 0. So what does that imply now? That implies what is a factor. So therefore, x minus 2 is a factor of gx. Remember, where do I get the negative 2 from? It's always with the opposite sign. Always. Okay, so that was the easy part. Here's the difficult section. And there are, the boys and girls, I'm the first person to say there's other ways of doing it as well. If you've got another one and it's mathematical correct, and you feel more comfortable, then you do the freaking thing. This is what I like to do. So now I've got x minus 2. So now what do? Now I go and I say, right, with what should I multiply that x to get to that, which is 2x to the power of 3? And the answer would be 2x squared. So bracket 2x squared. With what should I multiply negative 2 to get to that positive 6 I have at the top there? This one over here. And the answer is, and in the middle between everything, there's always going to be a bx. Okay, I say always. It could happen that there is not one, but we don't know that yet. What do we do now? Now we say, all right, those two and those two on the side. So that's going to give me negative 4x squared. That's going to give me plus bx squared. What should it be equal to? And it should be equal to whatever is written there, which is x squared. So here I'm going to have x squared. Now the x's fall away, so I get negative 4 plus b equals 1.
Sir,
Yes.
why don't the x's fall away?
Okay, so the x's fall away for the following reason. I can take out an x there as a common factor. So I'm left with this. Am I correct? And then I can take it across, it will cancel out and it's done. Okay, it just makes it easier for ourselves. So now 4 goes across. If 4 goes across, I add it, so I get b is equal to 5. So that means that I erase, you do that in pencil, and in there it's going to be plus 5x. Okay, so now it is a quadratic expression, that little section there. Sure, sir? Yeah, it's a lot of work. So now you do this. 2 and 1, 1 and 2. 3 and 1. You remember that thing? And remember, it's probably going to say without a calculator. So you need to show every single thing. So to subtract to get 5. That's 2 and 3 won't work. Here we go. 3 and 2 is 6. 1 and 1 is 1. 6 minus 1, yes sir. So there's my brackets. So now I'm going to get x minus 2. Now it doesn't matter which order you write the brackets. An x with a 1 and a 3. A 2 with an x and a 1. Signs will be different. Biggest one is a plus. Plus, minus. There's your factors. Done and dusted. The most difficult thing is factor theorem, which is actually not that bad. If you understand what to do there, it is just a little bit of work. I think the most difficult thing is getting that middle b to remember what to do. Yes, Stefan?
So do you have to write those factors out? So like
No, because the question asked, factorize it, not solve it. You can't solve this thing. It's not equal to 0. So you can't go and tell me x is 2 and minus 3 and positive a half. You can't do that because it's not an equation. You can only do that if it is a equation, if there's an equal to 0. Now, ladies and gentlemen, questions. Are you fine? I know this is like, just give it an opportunity, do 1 or 2, then you see you get into it. But you need to practice this. That's where the difficult section comes in, sir. It's difficult to go and do this on our own. Right, so here's one. Please factorize the following for me. I'm not going to say a word. You can do this one on your own. Number 3. And I say again, boys and girls, if you have the calculator, it makes life so much more simpler. Okay, so it says that, plus that, minus that, and then it says minus 6. Factorize that for me quickly, please.
I do not have my calculator with me. Can I please ask you factors?
The factors.
No, I just want to know what.
Now you're going to work it out with the factor theory. Huh? Oh, Stefan, he's got one with him. I also don't have mine here. Okay, mine is also down. Mine is really good. Well, yes, weer is een compleet gaten. You can use any of them. Doesn't matter. Just to be more convincing, use the lowest one. Otherwise, they're going to think like, why don't you use the lowest one? If you now did it without a calculator, understand? x plus 1 is then a factor. Yes, and now you can go and get the rest. Well, I did exactly what the book does, and I think the book makes a mistake here. It should tell you fx, gx or something, because what are you right? So if whatever you call it, so I'm just going to say the f of 1. And even though you know it's going to be 0, you have to indicate it, because this is the only proof that you have that you did it without the calculator. So therefore, x minus 1 is a factor. Doesn't matter, any of the two. Most of you use minus 1.
Okay.
Same thing. At the end, right at the end, you see, right at the end when you factorize it completely, both would be there. So I decided to use 1. Most of you decided to use, it doesn't matter. Nobody will be penalized. Alright, so then I go into x minus 1, and now I ask myself this. With what should that x be multiplied to get to that? And that will be 2x squared. With what should that negative 1 be multiplied to get negative 6? And the answer is positive 6. In the middle, I find the bx. I always call it plus bx. You can call it negative, not really. Keep it positive, it's just easier. And now I multiply and I say, right, those two and these two. And here on the side, I do my quick calculation. So that will become minus 2x squared plus bx squared is equal to what? Is equal to 6x squared. And then the x squares fall away. I'm left with that, which means b is 8. So into my equation here, I'm going to go and I'm going to substitute positive 8x.
Sir,
Yes.
at this stage you used another factor and you have a different answer for these 5.
It's fine. You probably, ladies and gentlemen, remember, if you use something else here, this most probably would look different. Doesn't matter, you're going to get to the same answer. Yes, Jamil? I'm going to just finish and I'm going to have a look. So the first thing that I already see here is, wait a minute, what can happen in this thing? I'm going to take out a 2. So I'm going to take out a 2, and I'm going to be left with x squared plus 4x plus 3, which makes my factorizing process of the quadratic so much easier. I need factors of 3 to add to get 4. Isn't that 3 in 1? So I'm going to be left with x minus 1, x1, x3. Signs are the same. Both are pluses. And there's your problem then solved. In other words, you guys used minus 1 at the top you won't get this, you'll get something else. But in the end, you have to have all three of those. And Stefan, if I'm correct, the calculator said the answers of x was 1, -1, and -3. I'm going to have you just ask me. Yes.
I don't know if so I'm going to my x's naught, and then this one's my
You just see, so that's 6x squared. This is bx squared, must be 6 there. So that's 5. This is 6. That's a b, I guess you get naught there. Which is fine, because I can take a 2 out there. But remember, plus or minus, what you are doing now is, you are solving the equation. So this is absolute nonsense. So it must be
plus minus and
both answers. Because technically you solved it, that's why I say. So the 2 must be in front at the end. Like Stefan had here, yes. Fantastic. Jamila, I'm on the way. All of you try this one quickly for me. It says the following. It says example number 4. Example number 4 says this. It says x to the power of 3 minus 7x squared plus 36. Factorize that for me. Yes, no problem. No problem. So what would your equation look like? Go on. So then that would become 0. So that would fall away. So you left with what? Bracket x plus 3. Bracket 2b x squared minus 2. Right? No.
Minus 2.
Yes. And what's x squared minus 1? Yes, exactly the same also. So ladies and gentlemen, just to this, 2 of you got to this. In the previous round, some of you got b equals 0. When you work this out, it is possible. Because then you're going to get not this, you're not going to get that thing, you're going to get this. 2x squared minus 2, which is 5. Take out a 2, and then it's the difference between 2 squares. You're going to get exactly what I have. Okay, you can do that one for me. Number 4. We're nearly done. Ek sien ek het dit misgesteek. Okay, ladies and gentlemen, please complete this one for tomorrow as well as on page 138, number 2 at the top. Please do the following for me. This one is one of them, so do for me 2.5 and then do for me 2.10, and do for me 2.6. And 2.6 and 2.10, I would like you to think a little bit. Just a little bit. I'm going to give you a hint with 2.10. Those of you who have been with me long enough, this was a fight we had in grade 9 when we factorized. Should we or should we not? You'll see it when you get there. Should we or should we not? Okay, you go back away, let's sanitize.